So the specific heat is the amount of energy that's required to go from to change 1 gram of water, or 1 milliliter of water, 1 degree Celsius. Now, for something like water, if you have 1 mil of water, that equals 1 gram. And so if we go and look at the equation for the specific heat of a material, we have an equation where Q equals mc delta T. It's also referred to as Q equals mcat, just to make it a bit easier to remember. And if you look on here, you've got heat. Q is the amount of heat produced, added, and that's measured in joules. It equals mc delta T. M is mass, that's in grams. Specific heat is in joules per gram degrees Celsius. We'll get to that in a little bit. And this is a change in temperature. So it's a difference between the starting and finishing temperature. So if you have a look at this example over here, we've got a coffee cup filled up with water. And if we go and heat that water up, the temperature that was reading here, might have been say 20 degrees Celsius, has now heated up and it's now measuring 30 degrees Celsius. So that's measured a total of a change in temperature of 10 degrees Celsius. So we could have an example where we have a coffee cup of water, so a coffee cup of water, which is, let's say, 100 mils, to make it nice and easy and round, is heated to, from 20 degrees Celsius to 30 degrees Celsius. And we want to work out how much energy is required for this to occur. So we're going to use that formula where Q equals mc delta T, and we're going to plug in some values. But first thing that we need to know now is the specific heat of water. So each material actually has a different amount of energy that's required to heat up 1 gram of it, 1 degree Celsius. So if I get something like these MAB blocks that I've got over the side here, each one of those blocks actually, so this one block here is 1 mil or 1 gram, as we said before. Now, to heat that 1 gram of water, if I get it and I heat it and I want to raise it by increase its temperature by 1 degree Celsius, well, looking at this table over here, this tells me that I would need to put in 4.1 joules, 4.184 joules, to lift up that 1 mil or 1 gram by an increase of 1 degree Celsius. I need to put in 4.18 joules. So the example that I'm now looking at is not 4.18 joules. I've now actually got, instead of 1 mil, I've now got 200 mils. So I want to lift up 200 mils or 200 grams, and I want to raise the temperature of that from 20 degrees Celsius to 30 degrees Celsius. So now I've got to try and figure out how much energy I'm going to require. Well, let's grab hold of this formula and I'll bring it down a little bit closer to where we're working, and put it over here maybe. And like normal, we're going to write down our data, where we have data, just like we've done before, and we've got Q equals M equals C equals, and we're going to put, maybe we'll put T1, T2, and then change in temperature. So the Q, well, that's what we're trying to measure. We're trying to measure the amount of energy. So it says up here how much energy is required. So we're measuring Q. M is your mass, and in this case it's 200 mils or 200 grams. C is the specific heat, and we get those specifics. They're a constant. And for water it's 4.184 joules. Let me just get a hold of this over here. And the temperature, the starting temperature, temperature 1 was 20 degrees Celsius, and the final temperature is 30 degrees Celsius. So the change in temperature is the difference between them, which is 10 degrees Celsius. And we're going to write down a formula. So you've got diagram, data. Well, here's our diagram at the top here. We've got data. Check our units. We've got grams, joules. That's actually joules per gram degrees Celsius. Degrees Celsius, degrees Celsius, degrees Celsius. Cool. Diagram, data, units. Select our formula. In this case, we know that it's actually Q equals MC delta T, or Q equals MCAT, where M is 200 grams multiplied by C, and over here we've got C is 4.184 multiplied by the change in temperature, which you just worked out was 10 degrees Celsius, and we multiply that out. So it's going to be 200 by 10 is 2000 multiplied by 4.184, and I'll just pause and get my handy dandy calculator. And after calculating it, that equals, let me just check that again, 8368. 8368 joules. In other words, we would require 8,368 joules of energy to raise 200 grams of water from 20 degrees Celsius to 30 degrees Celsius. Now, the example that we're actually going to be doing with the Austar dish, we're obviously not using the coffee cup. We're going to be placing a beaker on top of the Austar dish, right in the focal point. And in effect, what we're doing is we're measuring the amount of sunlight that comes in. So the sunlight that's actually coming in towards the dish, and it's hitting the beaker here. By doing research, we can find out the amount of energy in watts per square meter that's coming from the sun. So we'll call that the sun wattage. And remember, if it's watts, it's joules. Now it's actually joules per second, but it's a form of energy per second. And we can then go into the beaker here, and if we use the formula Q equals MC delta T, then we can figure out how much energy has actually gone into that beaker in the same time, which is joules. And if we know the time that we did that in, we have seconds, so we have the wattage that was actually placed into the beaker. And what we can do then is calculate the efficiency of the dish, where we compare the energy from sun to the energy placed, for want of a better word, into the water in the beaker. And that's essentially how we're going to calculate the energy efficiency and the energy in the beaker.